Hi and welcome back to Sorosa's classes. Today we'll be dealing with a chapter that is feared by almost everyone. We are going to do static equilibrium analysis, mainly dealing with linear models and matrix algebra in this video. Let's begin with a question. Over here we are given a two-industry economy. Notice I have underlined certain values. We are given that industry 1 uses 10 cents of its own product and 60 cents of the commodity 2 to produce a dollar's worth of commodity 1. Next we are given with industry 2 which uses none of its own product, that is its value is 0, and 50 cents of commodity 1 in producing the same amount of commodity 2. And in the open sector there is given a demand of 1000 billion of commodity 1 and 2000 billion dollars worth of commodity 2. Now we are usually given the question in the following manner. First we need to write the input matrix, the Leontief matrix and specific input output matrix equation for the economy. Next we are given with the check how to satisfy the Hawkins-Simons condition, and finally we have to find out the solution output level by Cramer's rule. I'll be doing one additional problem, stick around for more. Now I've written down the input matrix. Some may get it how it has been derived. For others, notice we have been given values such as 10 cents, 60 cents of commodity 2 and 50 cents of commodity 1 used by industry 2. Also notice there it has been written, as I explained, none of its own product, which will taken as the value 0. Hence I've put in 0.10, 0.60, 0.5, 0. 0.10, that is this first value, is industries 1 uses of its own product. 0.60 is its usefulness of commodity 2 while producing its first product. 0.5 similarly is commodity 1 used for production of 2, and 0 is industry 2's own product usage. This is called as the input matrix. Now we need to write the Leontief matrix. The Leontief matrix is obtained by subtracting matrix A from the identity matrix, that is I minus A equals to, that is it will be equals to 0.90 minus 0.6 minus 0.51. For those who have problem understanding what an identity matrix is, I equals to 1 0 0 1. An identity matrix is one in which there are 1 in the diagonal . Thus the matrix equation will be zero point 9 minus 0.6 minus 0.51, which is this Leontief matrix, into x, which will be x1 and x2, and the given which will be equals to the given demands, that is $1,000 and $2,000 in our earlier question. Now we'll be doing number B to check whether this data in this problem satisfies the Hawkins-Simons condition. Let's begin. For Hawkins-Simons condition, we need to find the principal minors of the Leontief matrix, that is beta 1 equals to 0.9, that is greater than 0. Also beta 1 equals to mod of I minus of A, which will be equals to 0.60, that is also greater than 0. Thus the Hawkins-Simons condition is satisfied. Notice these are the conditions to satisfy HS, which is the Hawkins-Simons condition. Next, moving on to number C, to find the solution output levels by Cramer's rule. For Cramer's rule, first we find delta, which is mod of the Leontief matrix I minus A, that is 0.6 upon calculation. You can do it on your own or refer to our video on Cramer's rule. Next, in the original Leontief matrix that we did, that is this one, I minus A, the 0.9, this was the equation that we had obtained. As I said, 0.9 minus 0.6 minus 0.5, 1 is our values. Now for Cramer's rule, we first find D1. For D1, we replace this demand function value first over here. Similarly, for D2, we replace this value over here. Notice when I put 1000 and 2000 in this area, this remains unchanged. Thus we obtain the values of the given modulus. Let's see what the values will be upon calculation. You can pause the video and figure it on your own and then check for the answer. Don't worry, we're gonna help you with everything. That is, we get D1 equals to 2000 and D2 equals to 4000. Now we'll find the value of this x1 and x2. How to find this? X1 equals to D1 by D. Here the value of D is 0.6 and D1 is 2000, that is 2000 by 0. Sorry, I made a calculation mistake. D2 has 2400 as its value. Now upon calculation, the value we get of x2 star is 2400 divided by 0.6, that is 4000. Now quickly we'll do a sum that is fairly theoretical, and theoretical questions are always a bit challenging to answer. Let's see what we have in the question. We have to explain the economic meaning of the elements 0.33, 0 and 200. Starting off with the first question, the element 0.33 is given in this area. This means 0.33 cents, 0.33 means 33 cents of commodity 2 is needed as an input for producing $1 worth of commodity 1. Similarly, element 0 in the third last area of the matrix, it means industry 3 does not use any of its own input, as we had done in the previous question. Next, the element 200 which is given here is the open sector demand in billion dollars, mind you, of commodity 2 that is required. Very easy. Next we'll be doing the economic meaning of the third column sum, which is this one. The third column sum is 0.34 plus 0.12, which equals 0.46. The meaning of this is 46 cents of non-primary inputs are used in producing $1 worth of commodity 3. Similarly, doing it for the number C, we have to explain the economic meaning of the third row sum. This looks easy, but it easy is. This is because this does not have any economic significance, because each individual column represents the input matrix for commodity 1, commodity 2 and commodity 3. The summation of these three does not have any economic significance. Hence, the result of number C is no significant economic meaning. Now, lastly, we'll be doing how to write the specific input-output matrix equation for this model. This will be the specific input-output matrix that has been asked for in the question. Now let's do an extra question. Let's check the Hawking-Simons condition for this. Remember how to do this? For Hawking-Simons condition, we'll be taking out similarly beta 1, which is equals to 0.95 greater than 0. Since it's a 3 into 3 case, we'll be also taking out beta 2, which is the minus 0.95 minus 0.33 minus 0.25 0.9, which comes to 0.7725, and beta 3, which is I minus a modulus 0.6227. Thus, since all these category are satisfied, hence this Hawking-Simons condition is satisfied for this question. Next, we'll be doing comparative statics in our next video. I will be going from the very beginning and the easy sums to some of the sums which are considered to be difficult. I'll show you how to do all those. Stay tuned and click our notification, like and subscribe button. See you soon. Thank you.